Now that you know what the shapes look like from the 4 toolbox, let's go ahead and move into section 4.1, which starts on page 246. In this section, we're going to graph some of the higher order functions whose shapes we talked about in the 4 toolbox. Now, to understand the graph, we start out with a function that looks like this. F of x equals plus or minus x plus or minus h to the power of n plus or minus v. Now let's break down each element of this to determine how it affects our graph. The first part we're going to talk about is the h. And h is horizontal, as in left and right. And because of our George rules, remember our Seinfeld, this is going to move the opposite way that you think because of the sign. In other words, if it's plus, it's going to move to the left. If it's negative, it's going to move to the right. That's called a transformation of the graph, a horizontal transformation to be precise. On the outside of our function, and we say outside of the function because anything contained in a parenthesis has a power, anything contained in a radical, because really that's just another way of saying a parenthesis with a power, those are part of the function. And anything part of the function is going to move the opposite way you think. On the outside of the function, this plus or minus v on the outside here, that tells us v for vertical, as in up and down. And plus means it goes up, and minus means it goes down. And then the shape itself is determined by the first plus or minus coupled with the power that we're dealing with. So this part here is the shape itself. So this breaks it down exactly how we're going to graph some of these higher order functions. First, we're going to determine what is the shape of it. And then second, we're going to determine how is it moving? What's the horizontal transformation? What's the vertical transformation? And then once we have that, it's a matter of graphing it. And yes, there's one more piece we want to get to it, which is what is the y-intercept? So really, our graphing comes down to a couple of things, right? It's understanding the shape. It's understanding the movement. And finally, it's understanding the y-intercept. And we know the y-intercept. It's where x equals 0. So now we're going to use this to jump right into 4.1 here. And precisely, we're going to look at example 1 on page 246. Now, we're not interested in doing the absolute value of x. We've already done that. In fact, we just did that if you watched the last video. So we'll instead focus on the part that has g of x here. And g of x says it equals the absolute value of x plus 3. So when we look at this one, we see that we do have an absolute value shape, so that we know what the shape is going to be the v, and it's going to be a positive absolute value, so we know that the shape is a v. So I'm giving myself a little v here to remind myself that that's what the shape should look like here in the end. There's nothing inside of the absolute value to tell us that there's any movement left or right happening, but there is a value on the outside, so it tells us that everything is going to move up 3 units. Now, I don't know if you caught it in the last video, but every one of our graphs had the same exact point on it, which was the point at the origin. Some would call that the vertex. Some would just call that a point on the graph or a starting point on the graph. Either way is fine, but all the graphs shared in common was 0, 0. So that's going to be our starting point for any movement to translate to our graphs of these other functions here. So the absolute value function normally starts like every other one here at 0, 0. There would have been a v this way and a v this way, right? Except now what we're going to say is it's still that v shape, because that's what this tells us. It's a v shape. Except instead of starting right here at the origin, what we're going to do is we're going to go up 3. So 1, 2, 3. We're going to put a point there because that is the new vertex spot, or starting point, if you will. And then we're going to draw in our v shape. And there we go. We just did example 1 on page 246.